Hello everyone. Today we'll be talking about building a brain in 10 minutes. We are talking about computer brain. But just to take a look at our human brain. In the human brain, in the biology, our biological neurons receive the signal through dendrites. And under the right condition, it sends the electrical impulse through the axons. This is a mechanism we aim to mimic. So our mission is we want to teach a computer to see the fashion. For this, we will be using an image. We will be using the image of 20 by 28 pixels. So we have two kind of data set. One is for the training. We will be having 60,000 images for the training purposes, and for validation, we have 10,000 images. So altogether, our model will pass through 70,000 images. Now let's examine a single piece of curriculum. So in this particular diagram, we pass the diagram, and for this particular diagram, we got the highest number for level 9, and that's the ankle. So now once again, this is the human brain, and now we are talking about the computer brain. We will be using X, the input, the 784 pixel. Every pixel we have the different weightage, and then we'll have the bias, just kind of offset, very similar to y-intercept, and the summation of these all will represent to the neuron resulting y. So how the program works? We are using Python, and for the simplification, I have taken out the TensorFlow part. So we are doing three things. One is stacking the layer, then using the flatten, and then the dense. So let's start from the model. So to initialize the model, we are using Keras module from TensorFlow, and we are saying just call the sequential, and while calling the sequential, we are passing flatten. We are just saying that we'll be passing each and every pixel, and then we are saying the dense layer will be the 10. Our strategy is very simple. We create 10 neurons, one for each clothing. We show the model to an image. The neurons that produces the highest order score will be the models. Yes, so let's summarize what all we talked about. So we are using the model sequential. We'll be doing the flatten. Our input will be all each and every pixel of the image. And the dense, for simplicity, we are just using 10. So total parameter will be 7,850. Let's see how. So our weight was 28 by 28, 74. So we'll multiply by, as we have 10 neurons, we'll multiply by 10. This becomes 7,840 weights. Bias, each of the 10 neurons has its own single bias value B, and that is a 1 bias multiplied by 10, 10 bias. So 7,840 plus 10 bias, all learnable parameters are 7,000. So this is how the connection looks like. The input layer where we are entering each and every pixels, and then the output layer, output neurons, the 10 neurons. So now we have basic building blocks. We will try to provide a grading system. So there is something which is going to tell us that our model is doing right or how far it is from the reality. So for that we are using sparse category cross entropy. That's a long name for me. Simply just say that we are using one of the loss function. What it does, it will be just calculating the prediction, and it will try to see how far we are from the actual result. So let's say our loss function 8113, actual number was 82, so it will be kind of little bit of difference. So let's say that uh, it gives the direction that where we are headed. So this diagram is just showcasing the 28 by 28. So let's say we provided one image for validation, then we got the highest score for the t-set, and then we'll label t-sets. So From our previous calculation, we have seen that our result is 85% accurate. And with our only 7,850 parameters, just think that in the real life, the data will be way more higher. So, what we did so far? We just walked through the entire process of designing, building, training, and evaluating a neural network. So, while this model does significantly better than random guessing, it has a way to go before it can beat human at recognizing plotting. Mechanism of neural network. That's all I have for you. If you like my video, please share and subscribe. Thank you for watching.